Building IoT apps with Azure and Particle, from device to cloud and back again, with Brandon Satrom.
So what we are going to do today, and the point of this workshop, is to really go through a end-to-end exploration of the Particle ecosystem. And let me drop my display size down, because I know that I have a really large monitor. So let's see, drop it down into 1080p mode. So hopefully that'll be a little bit more friendly for those of y'all that are following along at home. And all right, so drop my resolution down a little bit so it doesn't look so expensive. And Brian, thanks for saying hi in chat. For the rest of y'all that are hanging out, please feel free to say hi. I do have the presentation up, but I will happily answer any questions and interact with you folks on chat as well. So what we're going to do today, and we have 4 hours blocked out. We don't need to take the whole time. If we have questions, we can absolutely take the whole time. But I'm just going to start rolling through and working through all the various aspects of claiming a Particle device, introducing Particle primitives in the device cloud. We'll go through a couple of hands-on labs with that. And then I'll end with sort of a last overview of Particle integrations and Azure IoT Central. And if you're on a Wednesday, Paul DiCarlo from Microsoft was here with me. He's not here with me this morning, but I will give you some more info about him. But he did a great job with me on Wednesday, and so I definitely want to make sure to thank him for the work that he has done. As we're going through today, there's a number of prerequisites that I want you to keep in mind. First off, check out this link, and I will copy this down into chat. So let me copy that link over here real quick. And if you haven't done this already, the workshop content is at this URL right here. And it will also include the prerequisites. And these are some things that I want you to go through. You can go through while I'm talking here for the next couple of minutes. Create a new Particle account, install Particle Workbench, which is our Visual Studio Code extension. If you already have Visual Studio Code, you can open up the extensions manager and just search for Particle, install that. Or you can follow the download link in the docs. Install the Particle iOS or Android app, and then finally install the Particle CLI, and the instructions for all of those are available in the appropriate places at that workshop URL. So really briefly, who am I? My name is Brandon Satrom. I work on the DevRel team at Particle. I've been there for about 2 years, and what I like to tell people is my team and we just work on building cool stuff and helping our customer base build even cooler stuff to really show what's possible with our products so that you get to go through the experience of learning about Particle and working with the ecosystem, and then also helping with your feedback and help turning around and improving our products so that we can all build the coolest stuff. And my co-presenter from last week, who is not here with me today, but again, worked on some of this content here and did a great job on Wednesday, is Paul DiCarlo, who's a senior cloud advocate for Microsoft. He is definitely available to answer questions online as well, and I'll share info about his Twitter handle and how you can get in touch with him, and where you can reach him in the future. But let's just go ahead and get started. And I'm going to spend a few minutes talking about the Particle ecosystem itself. Really, there's 3 pieces of that. One is the why Particle exists. We'll spend a little bit of time talking about the Particle device cloud and all sort of the pieces of the Particle ecosystem. And then we'll get through the fun part, which is claiming your first Particle device. And for those of you that are here new today, I would hope at this point, since we gave you a little bit extra time, that you do have your hardware in hand. So we'll go through the exercise of actually claiming a brand new device and going through all of that fun. So first, why Particle? Now, if you know anything about us already, or perhaps if you don't, Particle we are a full stack IoT device platform. That is sort of the journey that we've been on over the last 7 years, is starting with IoT device hardware and firmware to having connectivity baked into our devices, providing secure connections to our IoT device cloud, and then providing you with SDKs, tools, and third-party services that make it easy to do the app development part of building an IoT application. And over the last 8 years, we actually just had our 8th birthday just last Friday. We have over 170,000 developers in our community in over 170 countries and over 500,000 devices that have been brought online. And in the course of our history, what we've really focused on is this idea of solving real problems for real customers. There's no doubt that the IoT in general has been really dragged through the mud in a lot of ways. It definitely is a technology, a hot topic that does have a bad reputation among some. Is definitely seen as silly, toy, hard to really see where real use cases are. But what we actually found over the years is that there are a lot of customers out there, customers of ours, that are looking to solve real problems in unique ways. They're using connectivity to do something that wasn't possible before. It was as simple as it is today to build something with a Wi-Fi or cellular-based solution. And because we focused on solving the problems of our actual customers, it's really led us down this interesting path with the kind of hardware and software that we've built over the years. And it started with the Spark Core, our early sort of first Kickstarter device from 8 years ago, to the Photon. And if you were doing any IoT prototyping or development back 7-8 years ago, then you likely know that the state of the art in those days was a $35 Arduino Uno or similar device. And if you wanted Wi-Fi, a $65 Wi-Fi shield that would sit on top of that. So a Wi-Fi based solution has set you back $100 in those days just to get something prototype connected, etc. And when the Spark Core came along and then nearly after it, the Photon, you had a $40 in the case of the core, but then a $20 option with a Wi-Fi radio baked in. And so we took that approach of making connectivity an essential piece of every single one of our products, every single one of our modules. And so we started with breadboard friendly dev kits that had Wi-Fi built in. You could buy them with or without the headers. They had castellated edges if you wanted to just solder them down into a board. But we had customers that came to us and said, I love your prototyping kits, but I'm ready to go to production. What can you do to help me with this? And so with that same tool chain, we provided the P0 and the P1, which are sort of our mass production modules. And so again, the state of the art 7 or 8 years ago was that if you were building something for a production-based solution, you would start with your prototype, vet your idea, build your prototype, and then throw the whole thing away and start all over again with either your own custom ASIC with a different device. You may have heard this story before around the Raspberry Pi. People will start with a Raspberry Pi and then throw it out and start from scratch for the production solution. And we wanted to provide our customers with the ability to use the same hardware ultimately for their prototypes and for scale. So the module that's in the P0 and the P1 is the exact same module that's on the Photon, but that you can integrate and embed into your own design. And the beauty of using that approach is that you can actually prototype and use the exact same firmware, because our device OS firmware runs precisely the same on prototyping hardware versus mass production hardware. You can use the same device, the same firmware in both places without having to scrap the prototype and start all over again. Now, a couple of years after releasing the Photon, we did have some customers that then came to us and said, hey, we love that you have cellular, we love that you have Wi-Fi. We're building solutions where Wi-Fi is not an option. We need cellular. And so we released the Electron, same sort of approach, a breadboard friendly dev kit, and then the E-Series, which was a device for actually going to production with either, and you could buy an eval board or E-Series modules that were castellated so that you could solder those right down into a custom PCB, and those were distributed in trays. And again, you have the exact same firmware, the exact same device OS that's available to run in both ecosystems. Now, last year, we introduced Particle's 3rd generation hardware with Bluetooth and mesh networking baked in. And that's the device that we're going to use today, is one of those devices, the Argon. Now, the reason why we pursued these devices, this style of device, is because we had customers that were asking for new options, right? They wanted new, the newer, more powerful hardware, but hardware that actually had new modern connectivity solutions baked in the form of Bluetooth and mesh networking. And we'll talk briefly about what mesh networking actually is in a future module. But for now, I actually want to get to the Particle Device Cloud and really the pieces that make up all the aspects of the Particle ecosystem. We talked briefly already about hardware for prototyping and production, But I wanted to talk about sort of the last two pieces here, our device OS for firmware and libraries, our device cloud and software tools, because those are important pieces of the puzzle. Now, when you're programming a particle device, you're building on top of something, our own real-time operating system that we call the Particle Device OS. The Particle Device OS is ultimately, as it sounds, it's the OS, the operating system that runs on every particle device, keeps things running, keeps the connection to the cloud healthy, resets and configures your device, but it also provides you with a number of features that make cloud connectivity really easy. Because one of the things that we wanted to be careful of when building connectivity solutions was we didn't want to just give you a Wi-Fi chip or a cellular radio on the board and then say, okay, now you're on your own for getting data off the device. Now, set up your own MQTT server, set up TCP, figure secure communication. We wanted to provide the good things that you want to do with connectivity really baked in. And so there's a number of convenience features that we provide in Particle's Device OS that allow that. We'll talk about these more in the next lab, but they are Particle functions, variables, publish, and subscribe. And in addition, we recognize that a lot of developers in our ecosystem are relatively new to the IoT space. We get a lot of people like myself that have more of a web or mobile or cloud development background that are attempting to build IoT solutions for their customers, getting into the space for themselves. And so we may not be as familiar with sort of the low-level programming constructs that tend to be at play in embedded application spaces. And so we also provide an entire ecosystem of a few thousand firmware libraries that make it really easy to abstract away the sensors and actuators that you tend to work with when you're working with an IoT solution. So it allows you to simplify interactions, to leverage contributions from Particle's community of over 170,000 developers, and to reuse code across projects, of course. And so the example here is actually a simple example of just using a small display from Adafruit. And instead of actually having to push bits and bytes around over the wire one at a time and deal with that at a very low level, using a library allows you to just print out text of the display, position text, etc. All those things you're used to doing at a more high level. Now, the last thing I want to talk about is the device cloud and software tools. And so there's really a few important pieces of this. The device cloud piece is sort of the secure connection. Anytime you're working with Particle devices and they're connecting to the cloud, there is a built-in secure connection between your Particle device and our device cloud that is managed that allows you to do a number of really important things. One of those things that I really like about the Particle ecosystem is over-the-air compilation and device updates. And so if you've done embedded development in the past, you may be familiar with this idea of having to download a tool chain for that device. A lot of other devices out there in the ecosystem, if you want to do local compilation, you have to get a GCC compiler, you have to install a certain tool chain specific to your device that may step on, or you may have version conflicts with other compilers, etc. By default, we actually provide you with the ability to perform compiles of your Particle firmware on our servers in our cloud. And so you can actually give us your user firmware and we give you a binary that can then be placed on the device. Now, one of the advantages of doing a cloud compile is that we can also flash your devices without them being physically connected to your computer. And so I encourage you to check this out. You'll probably have a connection to your device solidly through the workshop today, but it actually is possible. And you'll see this when we go through the web IDE experience, is that you can actually flash your device without having physical access to it, without having it connected directly to your computer, which is not only a great thing for speeding up development, but also really a fantastic way for updating devices that have been deployed in the field and may not be accessible. Now, when it comes to developer tooling, there's really 3 different IDEs that we'll work through today and that you'll find yourself using as a part of your Particle experience. One is the Particle Web IDE, or what we call Particle Build. The next is Particle Workbench, which is our Visual Studio Code-based IDE. And finally, the Particle CLI. And all of these provide a lot of the same features, with a few cases where power users may find themselves moving towards one IDE or the next. And if you're doing mobile and web development, we provide a number of SDKs for actually working with the various ecosystems out there. And this is an important part of the Particle story because we recognize that the hardware piece is really only the beginning for any IoT application. And so we try very hard to make sure that it's just as easy to work with your Particle devices from a iOS or Android app or from a web or Windows app as it is to program those devices directly. And so we won't cover those SDKs in particular in this workshop, but there are some resources at the end that will sort of point you to the right places to go in order to explore those a bit further. And we also provide the Particle on top of the Particle Device Cloud, the Particle Console, which is sort of your view of all of your connected devices. It gives you event logs for your devices, health diagnostics for your devices, so you can see how your devices are actually performing. And we'll look at that in a little bit. And then finally, integrations. And integrations are the piece where you can actually connect our device cloud to your cloud of choice. We have first-class integrations for Azure, the Google Cloud Platform, but really beyond that, anything that can accept a webhook can be integrated with a Particle device. And so we actually will look at the Azure integration piece here in the third module here in a little bit. So with that said, I think I was only about 15 minutes, so that's not too bad. Sort of go through the initial part, but let's actually get to the fun part of claiming our first Particle device. And so what I'm going to do now is I'm actually going to open up a camera on my desktop here so you can actually see a Particle device. Let me see if I can, yes, is that the right one? No, that is the wrong camera. So I'm going to go to a different camera. Right there we go. Okay. So hopefully y'all are all able to see that. It looks like it actually is showing up pretty well. I'm going to move off to the side a little bit, so you'll forgive me if my audio gets a little bit more distant, but I actually want to walk you now through the process of claiming this device. And so if you haven't already, grab your Argon, take it out of the box here. What you need out of the box is basically just the device itself, and then there is a separate, the device will come in this little blister pack here, and there's another pack for the Wi-Fi antenna. So you want to get those two out. And once you have gotten those out, you're going to want to plug your device in. I'm going to plug mine in here. Now, mine, I already went through setting up on Wednesday, but I'm gonna get it back to the state that you'll see it in. When you power it on, it's going to look like this. It's actually going to be blinking, what we refer to as blinking blue. Let's see if I can get my camera to focus there. These streaming cameras are so blurry. Maybe it doesn't look as blurry to you. And hopefully you can see this to some degree. This is the this little blinking blue here is called listening mode. So my device is in listening mode. It is ready for me to claim it. So the next thing that I am going to do is grab a cable for my iPhone so that I can actually screen share that as well. So give me just a moment. I'm gonna mute my mic, turn off my camera. I'm gonna grab a cable real quick and I will be right back. In the meantime, get your device up, get back in listening mode. And if you are following along, give me a thumbs up in the chat to let me know that you're still with me here. All right, I am back. Wade, Jim, thank you for the thumbs ups. Appreciate it. Claudia De Silva, not sure how to connect the antenna. Thank you for asking that question, Claudia, because I do want to make sure to cover it. This UFL antenna, when it comes out of the bag, what you'll want to do is actually plug it in on the left-hand side here where it says Wi-Fi. And again, I might be blurry there, but basically, if you're right above the A in Argon, you will take this little antenna, and it is, I guarantee you, the trickiest part of this entire process, actually plugging in this antenna. Sadly, these connectors are really small, but once you get it, you'll be good to go. Hey, Tim. Yes, Monday stream is on. It's happening right now. Hopefully you can hear me. I am just sort of going back through things. So Claudia, hopefully give me a thumbs up if you get the antenna connected. I do apologize if it takes a minute. Those antennas, it's just sort of a unfortunate reality. Okay. I'm going to switch actually to my iPhone now, because we're going to go through the next part of the claiming process. Yes, maybe. Come on. There we go. All right. So when you open up the mobile app, you will see all of your claimed devices. In my case, I have a lot. This one might be your first one. But what you want to do in order to go through the claiming, to go to the next part of the claiming process, is to click the plus in the upper right-hand corner, set up a new device. You're going to pick argon, boron, xenon, and you're going to want to pair with your device. What will happen is you're actually going to pair your phone to this particle device via Bluetooth, and that's what actually performs the configuration, claiming process, and all that good stuff. So there's a data matrix on the top of your device. It's not a QR code, technically. I guess we call it a data matrix. So you're going to scan that, and that gives your mobile phone sort of the secret key to claim your device. So I'm going to click Scan Data Matrix, and I will go over and find my device, scan it. At this point, I will click that, yes, I have attached the Wi-Fi antenna, and I'll click Next, and I will pair with my Argon. Now, what you are all going to see at this point that I am not, because I did claim this device last week, is you're going to see a screen that comes up and says, do you want to put the latest firmware on your device? And you do need to go through that process. It'll take a few moments. The reason why that happens is because when we ship devices from the factory, we apply the latest device OS firmware at the time. And then, you know, by the time that elapses between when we produce it and when you get it in your hands, we've likely shipped other versions of the device OS firmware. And so you're going to get it'll be a little while, basically. So we want to get the latest on there. So you'll go through that process, say yes, go through the download. You'll see some screenshots of that actually in the workshop source. So let me run into that real quickly so you can see it. Tim, everything okay now? You got, all right, you're back on. So you'll see something that looks kind of like this, right? Begin the update. It'll update the device OS, send it to your device, and you're on the next step. Now, this next step, what you want to do today at least, is when it asks you if you want to use the Argon in the mesh network, you will say use in mesh network or don't use in mesh network. Say click don't use in mesh network. At this point, you'll given a screen that says, hey, 100 of your devices, your first 100 devices are free. That's good. I don't think I know anybody yet. I mean, I have like 75 devices and I work for Particles, so you'll probably be okay with that limit there. So I click next, and then you're going to configure your Wi-Fi credentials. So you'll scan for Wi-Fi networks. I will choose my network and enter my password, which you will not be able to see. And then I will connect it to the device cloud. So that's going to connect to Wi-Fi, start a session with the device cloud. If this is your first time claiming a device, what you're going to see at this point is it's going to take a little while, but it's basically in the background. just assigning the device to your account, assigning the device to you, and then you'll be asked to give the device a name. Now, for those of you that weren't here on Wednesday, we had a little bit of a hiccup with power being out for a little while here at my house. So far, it has actually held strong for almost 30 minutes. So that's good news. I'm going to give it a different device or a different name, and let's just call it Happy Monday, right? Because it is a Happy Monday. It is a Happy Monday, right? Wade, if I hit use in mesh network, do I need to reset and reconnect? No, Wade, you don't. If you hit use in mesh network, then you're okay. You can continue. It's actually not going to affect anything here. You do need to go through the steps of setting up a mesh network. And I will explain the answer to that question in the next section briefly. Okay. So give me just a few minutes on that one, but you're okay to continue if you hit use in mesh network. So my device, Happy Monday, is all set up. So I can go done, and I'll see it here online. If you're following along, give me a thumbs up. Let me know that you're still good. Brian, great. Claudia, do I need to restart Bluetooth on my device to see the device, or do I need to open the Particle app first? It depends on whether or not you're using an iPhone or an Android. If you're using an Android, you might need to restart Bluetooth and then open the Particle device. If you're having trouble pairing, you need to restart Bluetooth on the device. iPhone, if you're having issues on the iPhone, you may want to go ahead and restart it as well. But otherwise, the way that the flow works should be pretty similar to what you're seeing here. You'll scan the sticker, it'll pair, and you kind of go on from there. All right. So once you have your device claimed, I'm going to show you a little bit of a trick for those of you that are already caught up or sort of up to this point. Now, if you actually go and click on your device and you expand, you go in and you click the device and you expand the little name on the bottom, you can see the device OS version, the IP address, the last time the device was heard, things like that. If you're seeing a number here that's not 1.4.2, which is the latest version of the device OS, I actually want to show you a little bit of a trick with the Particle CLI that can get you on the latest version, because that'll actually save you some time a little bit further down the line. So hopefully you already have your Particle CLI installed, and if so, you can actually run a command called Particle update. That is going to look for any device in DFU mode. And DFU mode is what we refer as device firmware update mode. So I'll show you what this looks like. I'm actually going to decrease the screen size here a little bit. To get your device in DFU mode, you want to hold down this mode button here on the left, and then hold reset and let go of reset, and your device will start blinking magenta, and keep holding it until it starts blinking yellow. When it starts blinking yellow, that means your device is in DFU mode. Then you can go back to the CLI at that point and call Particle update. And what this will do at this point is this will actually get the latest version of system firmware on your device. In my case, I already had it, but for those of you that may be down a previous version, like a 1.2 version, like whatever the mobile app put on your device, you'll want to get to 1.4.2 in order to continue. So this will take about 30 seconds. And once you have the latest, your device will restart. And you'll see it sort of flashing, blinking, sort of to give you an idea that the data is being transferred sort of throughout the process. I'm going to go back to my iPhone as my device comes back online. And okay, no problem. Claudia, do you have your device claimed? Everything good? Can you give me a thumbs up on that? You do. Okay, great. Good stuff. Yeah, so the next piece is to put your device into DFU mode, which I did just a few moments ago. Hold down that mode button and reset. Let go of reset. Keep holding mode until your device is blinking yellow. And then you will run this command here, particle update, that I ran before. And that will be in the particle CLI. You just need to open up any terminal window, whatever your terminal of choice is, in order to do that. So with your device connected, what you'll see in the mobile app is you'll see sort of a breathing blue ball here on the mobile app as well. You can click on the device. You can actually go over to the tab here called Tinker. Now, for those of you that actually have Tinker or that got your devices and this is the first time you're claiming them, you will already see something different than what I'm seeing here. I need to actually flash Tinker on my device because I have a different set of user firmware on there. And this is an important time to mention, with any particle device, there's really two pieces of firmware running on a device at any given time. There's the device OS firmware, or what we call system firmware, and then there's user firmware. And the user firmware could be the application that you run. But in the case of a device that comes straight from the factory, it's an app that we call Tinker. And Tinker allows you to do a couple of fun things with your device. And so if you can see this screen, you'll see that you'll be able to do a couple of different things. I wonder if I can't have two different QuickTime screens open at the same time. So I'll show you this really quickly, but if you click a pin like D7 here, I'm going to click D7, and then with any pin here, what this allows you to do is this allows you to perform digital reads and digital writes for digital pins. And in case of analog pins, analog or digital reads and writes as well. And so a digital read or digital write is basically just setting a 0 or 1, low or high on a pin, basically turning it off or on. And so that's what we want to do, because one of the things that is true of our particle devices is that every particle device actually has a little blue LED that is wired up to the D7 pin right here at the top next to the USB connector. So if I click on digital write on the mobile app, it'll show up as low. Let me switch back to that really quickly so you can see what that looks like. So you'll see when it gets there, now I'm now set as low. And if I click it again and it changes to high, go back to my camera, you'll see that the D7 LED is on. If I click it again and set it back to low, the LED goes off. Click again, the LED turns on. So we're actually now in real time controlling our particle device without actually having to write any code, which is pretty exciting. And that's a little this little bonus piece that you get from me from being here live. That's actually not in the instructions here. But I do actually now want the next piece. Now that we've actually claimed those devices and we've gotten kind of where we want to be, we have them in our accounts. We're actually going to go through programming them very briefly using particle build, or what we call the particle web IDE. So for this piece, what I want you to do is go to build.particle.io, and you're going to create a new application. So you got to give it a title, and we will call it, I'm going to call mine Monday LED. And I'm going to hit enter. And once I have done that, I will see sort of a code window here in the main part. If you have not done microcontroller development before, just a couple of brief things to say about this. Your main code file can either be a .ino file similar to Arduino or a .cpp file, but it needs to have two things, a setup function and a loop function. The setup function runs once right when power is turned on your device, and the loop function just runs over and over and over again. The loop runs very fast, around a millisecond every time. As soon as you get to the end of the loop, it goes right back and starts again at the top. So we're going to do sort of our now equivalent of turning on and off that D7 LED, but we're going to do it ourselves in code instead of using Tinker. And so the first thing that we're going to do at the top is set the pin for our D7 LED, and then we're going to set the pin mode. And the way that pin modes work is we're basically telling Particle that this given pin is either going to be an input or an output. An input is a pin that you want to read its value from, and output is something you want to write to. Because this is an LED, we're going to actually write to that value. So that's all we need to do in our setup. And now, inside of the loop, we're going to digital write the pin high. We're going to delay 1,000 milliseconds. So delay basically just pauses execution. If I didn't do this, and then I called the next line of setting my pin to low, then it would turn on and off so fast that you wouldn't be able to see it. So I have to delay for a minute to slow down so that our eyes and brains can actually discern that something happened. Turn the light off again, delay, and then I am done. And then I will actually be done with this. So now what I'm going to do is save. Just hit Command S to save this. And in order to choose which device that I want to send it to, I am going to hit the little target here to open all of my devices. And you'll see if you already have a Particle device or multiple Particle devices claimed to your account, you'll see these categorized and listed here by the kind of device that you have. If it's your first one, only one will show up and you don't need to take this next step. But you do want to choose, if you have multiple, find your device and actually click the star on the right one. So I'm going to click Happy Monday. And then you can expand that device to actually see a little bit more about it. And so you'll see that I want the device OS 1.4.2. That is the default. Oh, my device window closed, and it opened and closed again. And then a cool thing that you can actually do just to sort of play around, if you ever have a lot of devices, you're not sure which is which named which, you can hit the signal button here, and this will actually cause your device to start what we call shouting rainbows. So let me go back here. And it actually will sort of go through the RGB, just color cycle through all the RGB colors and start telling you, okay, this is your actual device. You're signaling that. So I will stop that. It goes back to happily breathing cyan. And I am now going to just click the lightning bolt, the flash icon here in the upper left-hand corner. That's going to flash this latest firmware. And what's cool about this is even though my device is connected to my computer, what's happening right now is it's actually building my firmware in the cloud, taking that binary and putting it on the device without any local compilation actually happening. That'll happen for you. For your first flash, it might take a little bit longer after you've claimed the device and everything. But you'll notice now that my LED is blinking on and off every second or so. So cool. Hopefully y'all have gotten to this point. Give me a thumbs up. If so, let me know if you haven't. If you have any other questions, anything like that, I'm going to take a drink of water. All right, awesome. Thank you, Jim. I appreciate it. And for the rest of you, if you're getting to any point, like as we go through today, please, this workshop content will continue to be available. I will continue to leave this up and live from now until the end of time. Very likely, I'm not going to be taking it down anytime soon. If you fall behind, this content is the exact content that I'm going to be going through today. Cool. Thank you, Tim. The same content that I'll be using today, you can reference it now, reference it later if you got to jump off or anything along those lines. This is yours to keep as a part of attending this workshop. So cool. We have gotten through the first piece. Let's actually now go to the next section. And I'm going to spend some time talking about particle primitives. But also, I will talk about particle mesh because I do believe there was a question. Yeah, Wade, you had a question about when to use a mesh network and all that good stuff. So we'll spend a few minutes now actually talking about that. I will give you sort of a brief overview of the Particle console really quickly, talk through the Particle primitives, sort of key pieces of Particle's device OS. I will talk about Particle Gen 3 hardware and mesh, and then briefly mesh publish and subscribe as well. And then we'll get into the second hands-on lab. First, managing devices from the console. So console.particle.io is your sort of command center for all of your connected devices. It is sort of the place to go to figure out, sort of find the last time your devices appeared online, the types of devices they are, the names, IDs, all that kind of stuff. It is also the place where you see real-time event logs, both events from the Particle ecosystem, but also events that you may publish, as we'll talk about in a few moments. If you're working with cellular connected devices, this is also, the console is also your place for inspecting and analyzing the amount of data the data that your SIM cards have registered, the amount of data that you're actually pushing through those devices, and you can set limits so that you don't go over any caps that you may prefer to set on those devices. And then if you ever get to a point where you're going from, right now we're just looking at prototyping a single device, but as often the case with IoT applications, you need to at some point manage a fleet or a set of devices. We provide tools for making it really easy to take your firmware into production and actually start to take a single piece of firmware and apply that to an entire suite or set of devices depending on your needs. And you can release firmware, you can create device groups for firmware so that you can have test, dev, test, production, staging devices, and actually release firmware updates to devices in the field. And again, because of OTA, over-the-air device updates being something that we provide, you can release firmware updates to devices without having to have physical access to them, which is pretty cool. You also have the ability to view diagnostics across your fleet of devices, to look at fleet health, metrics, things like that. I encourage you to really explore the console as you start to play with your Particle devices, because there's really a lot of cool stuff there at your disposal. And then finally, the console is also, as we'll see in just a little bit, a good place to debug and inspect cloud variables and functions as you're working on building with your firmware. So along those lines, let's actually talk about those primitives. I hinted at these already a little bit in the last section, but these will become your friends when it comes to working with Particle devices, because again, we wanted to provide our community not just with connectivity baked in, not just a Wi-Fi or cellular module, but the ability to securely, safely, quickly actually share data from firmware, share data from devices, to remote control at sensors and actuators on a device as well. And so there are a lot of great APIs underneath a Particle class in Particle's device OS. But the four most common that you'll explore and that we'll walk through today are Particle functions, variables, publish, and subscribe. And so Particle variables are, as they sound, and I'll throw this off here to the side, it exposes a firmware variable to the cloud. So the whole idea is that you have a piece of state that is saved on your device. If you're reading from a temperature sensor, and so you have that current temperature reading always being collected every single time you go through the device loop, you can save that in a variable and in a global variable in your firmware. And then Particle variables allow you to basically forward that value to the device cloud, so that anytime another device or a mobile app or a web app needs to actually pull that value from the device, you can securely pull it because it's been marked by the device OS as a variable that you can read. And this is viewable from the console as well, which I mentioned. Functions work in the opposite way. So where variables are all about keeping a piece of state, sort of exposing sensor data to the cloud, functions allow you to actuate things on devices. So this exposes a firmware function to the cloud. So if you had your Particle device that was connected to a pump, connected to a solenoid valve or something along those lines, or even a servo, and you wanted to turn that pump or that solenoid off or on, you could actually have a piece of firmware that does that, actually actuates the pump or the motor, the solenoid, and then a function that can then be called securely by devices that you own, by other applications through Particle functions. So you can actually turn that remotely. You can build that into a mobile app. You could build it into a web app and actually interface with your devices without, again, having to physically be present in front of the device. And then the final piece is Particle Publish and Subscribe. And this is our pub sub mechanism for actually being able to take data from your devices and just forward an event to all registered listeners. Like a true pub sub system, Particle Publish doesn't know how many other listeners are actually listening. It just puts that publish event out there, and anyone that is authorized to read it can read it, etc. And so this enables device-to-device communication, and it's viewable from the device console. And then subscribe. And Particle Subscribe is the other side of it. Just subscribes to all events published by your devices. It's cool because it enables device-to-device communication, obviously, so you can actually have two devices that are not on the same network that can publish and subscribe events between one another. But it also is what allows non-IoT devices to trigger events. And so as we'll talk about in the third module here today, Particle PubSub is what allows our integrations to work. It's actually a Particle Publish that we'll be subscribing to on the integration side to put data into Azure IoT Central. That's sort of the mechanism that really makes that possible. So in the next couple of minutes, before we actually move on to the hands-on lab part of that and explore particle variables and functions, let's actually talk about Particle's Gen 3 hardware and mesh. And I spent the first lab talking a bit about this already, but Particle has three newish devices that we consider a part of our third generation hardware. There's the Argon, which you have in your hand today, and that is our Wi-Fi enabled device. The Boron, which is an LTE M1 device, and then the Xenon. Now, the Xenon does not have a Wi-Fi or a cellular radio inside of it. It is meant to function exclusively as a Bluetooth or mesh device. And so this is the device that allows you to actually create networks of devices that can work together in concert, which I'll talk about in just a moment. If you're at all a fan of Adafruit and the Feather form factor, all three of these devices use the Adafruit pinout, and they use a mesh networking protocol based on OpenThread. And they're all built around the Nordic NRF 52840, which is an ARM Cortex-M4. It's a 32-bit processor. You have a mega flash and 256K of RAM, and it does have Bluetooth and NFC capabilities as well. Bluetooth and NFC, I don't have hands-on labs to cover those today, but there are actually pointers to other labs in the Particle docs that you can explore, actually explore the Bluetooth capabilities of these devices, because those are pretty fun as well. The Argon, the Wi-Fi device that you have, uses an ESP32 as its Wi-Fi coprocessor, and also has an additional 2 megs of SPI flash, 20 GPIOs, and a few of my favorite features here that are new to Particle devices is there's an integrated LiPo charging and battery connector, so you can make your devices portable by charging a LiPo battery, and a JTAG connector for debugging. So you can actually, inside of Visual Studio Code, do on-device debugging of your firmware in real time, which was pretty darn cool. The Boron has all the same device features because it's ultimately the same chip, but it does have a different modem because it's cellular. It uses a u-blox Sarah R410 modem, so that's our LTE Cat M1 module. And then finally, the Xenon. And the Xenon has Bluetooth as well, but also provides mesh networking support. So I have danced around mesh a little bit. I'll go ahead and talk about it now. But the mesh concept, the idea of mesh networking, really goes back to Google, and Google and actually the Nest team at Google. But when Nest first created their smoke detectors, they were really trying to solve a different kind of problem than they had with their thermostats. Their thermostats are plugged into the wall. They're running on mains power. So having a Wi-Fi module in those devices is fine because these aren't low power devices. But smoke detectors tend to be battery operated. And so to put a Wi-Fi chip in a battery operated device is usually asking for trouble. The batteries aren't going to last very long. We'd have to change our smoke detector batteries way more than we do already today. And so they really went back to the drawing board with figuring out the right radio to put in these devices. They assessed Bluetooth, but ran into a different problem. Smoke detectors actually, because they're safety products, not convenience products, they actually they multicast, right? When you think about the smoke detectors that are in your house today, when one room detects smoke, they need to notify as quickly as possible all of the other smoke detectors throughout the house to get everyone else, to basically get everyone else out as quickly as possible. And so Bluetooth doesn't work because it's point to point. So what do you do if you're a company with billions of dollars and the ability to solve problems in your own way? You create a solution. And so what the Nest team at Google did is they created their own protocol called Thread, and they open sourced it and released it under Open Thread, and created a group, a standards body that really works on this group. Particle is part of that group, as well as Bosch, Texas Instruments, Nordic, Amazon, Analog, Samsung, really a lot of other organizations that are a part of that group. And at its core, Thread is a low power networking protocol. It's designed to give you the ability to create peer-to-peer or mesh networks around IPv6. These are wireless personal area networks. There's no single point of failure, and these are perfect for IoT scenarios. And one of the great things about them is that it's not a replacement for Wi-Fi or cellular or Bluetooth, but really something that's meant to be used in concert with these. Because the whole idea is where you have today in your hand an Argon, which is a single device with a Wi-Fi chip inside of it. Mesh networking gives you the ability to set up a collection of devices. You can add a number of Xenons in addition to that Argon that all are connected to their own devices in a network. One can be connected to a motor, one can be connected to an LED strip, one can be connected to something else, and they can all work together, but only the Argon has the Wi-Fi connection to the cloud. All the other devices work in concert in a local network without having to have a Wi-Fi or cellular radio on them. So when we talk about particle mesh, that's really what we're talking about, this ability to then form a local network of devices that can actually play nicely together. So you have your gateway device. Your gateway device is an Argon or a boron. This is the thing that's connected directly to the particle device cloud through its Wi-Fi or cellular radio. And then you have a series of other devices, Xenons primarily on the network, that are connected directly to your smart fridge, your smart lamp, your smart mailbox. And then repeaters, those connected devices function as endpoints. And then repeaters, which function as the devices that sort of allow the network to pass messages from one to the next. And the beautiful part about all of this is the way that particle mesh works is you don't actually have to define any of these roles. The gateway is a gateway because it's the device that has the network inside of it. So when you asked the question earlier, Wade, when you set up a device with a mesh network, you're saying, this is my gateway device. This is sort of the main device that's connected to the network. Any other device that you bring onto that network after that, if you have a Xenon on hand, and I encourage you to check this out for yourself after the workshop today, if you wish. If you have a Xenon in hand and you want to add that to the network, it's really a simple process of going into the mobile app when you claim that second device, choosing use in mesh network, and then adding it to your first network, to that first gateway. And now you have two devices that can actually talk together and work to form a more resilient network between them. And what's cool about this is that you can actually, in the context of a mesh network, use something very similar to particle publish and subscribe, but only for local messaging on the network. And that's mesh publish and subscribe. And so we provide a wrapper around UDP-based multicast messaging that allows you to publish events from one device and then subscribe to those on another portion of the network. And the beauty of this is that even if that connection to the network is down and the gateway is offline or the particle device cloud is down, everything here on the local network itself still continues to operate. So those devices can work quite well together. And so much like particle publish and subscribe, you can publish an event to all devices in a mesh network. And on the subscribe side, listen to all the devices on a mesh network. And the APIs for this are very similar to particle publish and subscribe. Similar to doing a particle publish. In fact, all I did here in this example was just swap out the particle class for mesh. Right, so I have my same example here. I want to publish a critical temperature warning. I just call mesh publish, give it the name and the value. And then on the subscribe side, I'm just doing the opposite. I'm just subscribing to a value and then passing that off to a function that I want to execute when I actually see that event come in. So I know that was a bit of a whirlwind. We're actually going to get a little bit deeper on some of the particle device cloud stuff. I'm not going to cover any of the mesh stuff today because you don't have a second device in front of you. But if you do have a second device that you're not using it as a part of today, or you want to grab another particle device like a Xenon, you can go to docs.particle.io really at any time. And we have in there, I'll show you this right now, a little bit of an aside. Cool, thank you very much, Wade. I appreciate that. I was about to ask, make sure that was coherent. So if you go into the workshop, go to docs.particle.io and go to workshops. There is an entire Mesh 101 workshop here that you can actually go through if you have one of those devices on hand. So, all right. So we're actually going to get to the second part of our hands-on lab here. And we're going to start with Particle Workbench. Before we do that, though, okay, cool. I was going to ask, does my Photon have mesh capabilities? By the way, no, it doesn't. So thank you for that question, Wade. That's a great question. One of the reasons, or the reason why it's possible in Particle's new devices to perform mesh networking is because they're all built on the Nordic NRF52840 chip. And that Nordic chip is actually what has mesh networking capabilities baked in, and we provide our APIs on top of that. So the Photon does not use the Nordic chip. It uses a different chip called the STM32, and that does not have mesh networking baked in. So yeah, if you're wanting to do mesh, it's with the newer devices. Okay, so in the second lab here, what we're going to do is we're going to go through working with particle primitives and the Grove sensors in our little second kit here, but we're also going to explore using Particle Workbench. So let's actually start with that piece first. I'm going to open up a new window in Particle Workbench here. And let me get my... All right. So like I mentioned before, hopefully you already have Workbench installed and Visual Studio Code installed. If you do already have Visual Studio Code installed, you can install Workbench by just going to the Extensions tab and searching for Particle. This will bring up a couple of different options. The one you want is Particle Workbench, which is actually all of these extensions sort of included in there. We already have that installed. If you don't have Visual Studio Code or Workbench, you can follow a link in the instructions to show you where to go in order to install that. If this is your first time opening Workbench, you'll see a screen like this. Welcome to Particle Workbench. Sort of shows you there's a couple of different options here, links to docs, IntelliSense snippets, things like that as well. And the important thing to know is how to use the Particle command palette. The Visual Studio Code command palette, because this is really everything that we're going to be doing for the rest of the workshop here centers around using the command palette to execute different features inside of Particle Workbench. And the instructions on what that looks like or how to invoke the command palette are right here. If you're on Windows, you're doing Shift Control P. If you're on Mac OS, you are Shift Command P. And that's what opens the command palette for you. So I'll open Shift Command P. And you'll notice here I have a lot of different options. I want all of my particle options are underneath the name particle, so you can see all of these different things. If you are opening Workbench for the first time, if you haven't used the CLI before, the first thing I want you to do is run particle who am I. Running particle who am I will, will check to see whether or not you're logged in. And if you're logged in, it'll pop up down here to say logged in as Brandon at particle.io or whatever your account name is. If you are not, you will want to do particle login. Right, so run particle login. It'll ask you for your username and password, your two-factor token if you have two-factor auth enabled. Hopefully you do. And so once you're logged in, you'll be able to go through the next part of this process. So I want to open up the command palette and click on Create New Project. It's a little bit ways down. Create New Project will ask me the name of to choose a parent folder, which that'll go in. So I save all of my particle projects in one folder. So I'll choose that as my parent folder for the project. I will give my project a name. And I think I'm going to call it Monday Lab. Monday Workshop. Monday is the theme today. Monday Workshop, and it'll say, okay, is this the right path? That's the path I chose. That'll create that. It'll go through and initialize the project for me. Now, on initialization, you'll see a couple of different things that show up in the folder on the right-hand side. It's taking a while for me today. Slow initialization. I am happy to take any questions that come up while I'm waiting for initialization to actually happen. There we go. See, I knew offering that would be all I needed to say in order to get it to actually happen. So once your project is initialized, you'll get a new project, a new window with a couple of different things here. There's a README that gets created by Visual Studio, by Workbench. There is a project properties file, which has the name, and as we'll see in a little bit also is where libraries will be stored. There's a VS Code folder and then the source. And the source is what actually has, you'll see this looks the same as what you saw in Build, the web IDE a little while ago. And this is where we're going to be writing our code. Claudia, great question. What exactly is the difference between using Workbench and the other tool we used? That other tool was the web IDE or Build. So Claudia, the difference really is the web IDE is a great starter tool. It's a great way to explore the particle ecosystem. Once you've claimed your first device, it is what allows you to do cloud flashes without having to have a physical connection to your device. And I recommend you can continue to use that as long as you want. I tend to use Particle Workbench because I think that's sort of the next step up in terms of being a more professional tool. It provides a few more features. It provides you the ability to do local compile and flash, which will be slightly faster than always relying on the device cloud to perform flashes for you. And it also provides a few extra features like on-device debugging, which I mentioned in the last section. So you can absolutely continue to use Particle Build. Particle Workbench provides everything that Particle Build does and more. So it's just sort of like a next step up in terms of tooling. So hopefully that answered your question, but let me know if not. So I'm taking out some comments here, some of those canned comments that are in there. And there's a couple of different things that you will want to play with here on the command palette. A few things that I want to mention is that there are some buttons at the top here for compiling your project, for flashing your project, calling a function, or reading from a variable. So you can actually do those from within inside of Workbench. By default, the compile and flash buttons are local compile and flash, right? So if I were to click this, this would actually try to locally compile to my device. Tim, I think long-term Workbench would be the best way to flash firmware to a device, and I think that's fair. I think it does tend to be for a fast development workflow. It does tend to be faster to use Workbench to just do a local compile, local flash, etc. And that's what we're going to do through the rest of the workshop here today. So these are local by default, but if you go into your settings for Particle Workbench, you can actually see in Particle Workbench settings, you could change the compile button action and the flash button action to do something different. So they're locally flashes. You can change that to be a cloud flash or whatever you want to be. By default, it's local, but you can change it if you prefer, if you find yourself cloud flashing more. So that's the other thing I want to mention. So you can actually cloud flash here in Workbench, just like you can in Build. But if you would prefer to do local, Build is the only way. Build is really the way that you're going to be able to do that. So before we go any further, we're actually going to want to continue our workspace here for the device that we claimed in the last lab. So we're going to open the command palette again, and I'm going to choose Configure Project for Device. I'm going to choose Device OS at 1.4.2. I'm going to choose my Argon, and then I'm going to choose either the device ID or the name of my device. Now, I called my device Happy Monday, so that's what I'm going to call it. Happy Monday. Hit Enter. And what this does, this is actually basically tells Workbench, this is the device that I'm looking for. this is the one that I actually want to flash to. You'll notice too that it also will say something like this, sometimes compiler toolchain available. If you chose a version of the device OS that you don't have a compiler toolchain installed for, it will go and transparently in the background install all the tools you need in order to successfully locally compile and flash to your device. And that's an important distinction that I want to make. I said earlier that one of the advantages of the cloud compile is you didn't have to mess with installing tool chains and having to deal with conflicting toolchain versions and things like this. And that's still valid. One of the ways that we get around that in Workbench is that we install a compiled toolchain sort of in a .particle folder that's underneath your user profile. So we're not stepping on any other toolchain. If you're doing ARM development or working with Azure Sphere devices or anything along those lines, we're not stepping on any other toolchains that you might actually have installed. Great question from Marcus. Is it possible to use Particle Workbench in full version of Visual Studio? Marcus, as of today, it is not. But I do know that that is something that we've had requests for. And if you, I can get back to you on what our plans are for sort of extending Workbench support in Visual Studio. It's not today, but we are hopeful to get to that point sometime in the future. Part of the challenge there is that extensions are different in VS Code than in Visual Studio, but I do believe some of that is being unified or brought together just a bit. So I think as we get to that place, it'll be easier for us to provide Workbench support in both of those environments. But in the meantime, it's just in Visual Studio Code. All right, so we set that version correctly. And now in order to test this out, let's actually just do a compile application local. So open up the command palette again, or click this little check mark button here. This will actually open up a terminal window and will just perform a quick compile of the code that you have, which is not really much of anything. It's just a simple empty setup and loop, but it'll just use your local tool chain, creates a binary that represents the system, the device OS version that you're targeting, 1.4.2, and your version, your actual firmware, which in this case, like I said, is just nothing. Let's wait for that. And there you go. You have a binary that is now just under 5K, so a very small binary that you can flash to your device. But we're not ending there. We've got a lot more to do. And in order to go through sort of the next part of this lab, we're going to go back to our Grove Kit, back to our desktop, and actually unbox our Grove Kit. So let's go through that here. And if you have not already, I'm going to bring my mic over closer to me. So for the rest of this particular lab, we're going to use 3 of the devices here in this Particle Grove Kit, or 4, including the shield. There's the shield that the Argon plugs into, and what this provides is a number of convenient ports for actually plugging the other devices into. I find that these kits are actually a really great alternative to messing with a lot of breadboards and jumper wires. Instead of messing with individual little fiddly wires and small tiny holes, you can actually just easily plug devices in. So inside of our Grove Kit, we want to find a few different devices. You want to find this bag has the Grove Shield or Particle Mesh. So that's what this looks like. So you want to take this out, put it off to the side, and you're going to look for 3 different devices as well. You want, and these are already plugged in, but we'll walk through these briefly. You want the particle temperature and humidity sensor, the chainable LED, and the light meter. And they look a little bit like this, and they're labeled as well on the top. You're also going to want 3 of the cables from the bag that's in here as well. These are your Grove connector cables. And they're all identical. They're all basically just 4-wire cables that make it really easy to plug any of these into any device on the kit. So in order to move forward here, we're actually going to take our Argon, and you're going to plug it into the shield. Now, this is very easy to do because these only go one way. There are only, I think, 12 pins on this side. And so, is it 12? It's only, anyway, I'm not a count right now. There's only one way to plug this in correctly. And so you will plug the Argon into the shield. It'll go in pretty easily. That's your first step. Now, the next sensor that we're going to use, or the first sensor that we're going to use, is the temperature and humidity sensor. So this is a really nice little low cost, it's called the DHT11 temperature and humidity sensor. That'll be easy for us to work with. And so in order to get this connected, you're going to take one side of the cable and these cables all also only go in one way. There's sort of a little bit of a lip there on either side. It's got to focus, but you can see it. You plug that in on one side. And then the other side of the cable is going to go on the port that's labeled D2. You'll notice that each one of these are labeled something. We have an analog pin on the top, 2 digital ports are on the side. There are 2 I2C ports down here for using more complex devices. There's a UART if you want to do a serial connection between devices, and then 2 analog ports on the other side. This one is going to plug into the D2 side. Again, it only goes in one way. And once you are plugged in, we are ready for the next step. So if you're following along, give me a thumbs up if you have your device plugged in like so. We're going to move back to firmware. Thumbs up, thumbs up. Thank you, Jim. All right. Thank you, Wade. Okay, so on the firmware side, I mentioned in the first module that, thank you, Tim, when we're working with devices like this, there are some devices that are very simple, simple to program. An LED, like the D7 LED that's on Particle devices, is really easy to work with. It's really just a matter of setting it as an input or an output and then writing it low or high to turn it on or off. Thanks, Wesley. There are more complex things that you can do, of course, with those devices, but the programming interface of an LED is relatively simple. With a more complex sensor, the programming interface tends to be a little bit more robust, is probably the nice way to put it. And there's a whole lot more code knowledge required of the device and reading of data sheets than I would want to put in, and many of you would as well. And so firmware libraries create really, really nice, clean abstractions and APIs on top of those devices that let us to just get to the thing we want. In this case, the thing we want is to read the temperature and humidity. I just want to do that in 2 lines of code, and a firmware library enables me to do that. And so to install a firmware library in Particle Workbench, you open up the command palette and click on Install Library. Provide the name of the library. In this case, the name of my library here is Grove Temperature and Humidity Sensor. It's a mouthful. I recommend copying it from the tutorial, pasting it in here. Once you've provided that, what Particle Workbench is doing is fetching the source of the library and pulling it down into your local project so that you can work with it. So that'll take just a moment as it installs it. And after it installs it, you'll notice that you now have a lib directory and a folder for the Grove temperature and humidity sensor. And if you open your project properties, you'll see that a dependency has been added here as well. The nice thing about adding this dependency is this is what the cloud compiler uses to determine how to build your firmware. So you could still take this source and go to build or go to the cloud compiler and get a binary without having to have it installed. But when you're running locally, having that source locally is really advantageous because you can actually view the source for the Grove temperature and humidity sensor and see exactly what it's doing. You can view examples. Most firmware libraries come with demos, examples, so you can see how easy it is to actually use this thing. And that can be really useful. And if you notice in the demo here, this is what we want to do. Ultimately, we just want to be able to get float values of our humidity and temperature, in our case in Fahrenheit. And that's what this library enables us to do. So the first thing that we're going to do at the top of our firmware is include that library that we're using. So this is C++ world. So we need to actually include our dependent libraries, include their header files, in which case here I'm just going to call include Grove temperature and humidity sensor. And then the next step is to initialize the sensor right after my include statement. So I'm going to create a new instance of the DHT object, and I'm I'm going to tell it which pin it's on. In my initializer, or my constructor, excuse me, I'm passing in the pin that it's connected to. In this case, it's that D2 pin. Right? And my setup, I'm going to do a couple of things here. One is I'm going to start my serial monitor. One of the quickest ways, or one of the best interfaces for actually seeing what's going on in your firmware is by having a serial console window open and outputting, or basically debug logging statements to the console. If you are a web developer by background, this is your console log, right? This is your seeing what's going on in your firmware, inspecting values just locally from within your device. Now, this does require that your device be connected to a serial port on your machine. Otherwise, it doesn't work. So if you're working with just cloud compiling in a disconnected device, instead of doing serial prints, you can send values up to the Particle device cloud and do a little bit more inspecting of values that way. But for these purposes, we'll use the serial terminal here. Now I actually want to call the DHT begin, not DHT bean, DHT begin to actually initialize that sensor. And then from here inside of my loop, I can actually take the values, take the readings, and write them to the serial monitor. And here I am not going to hand code everything because nobody wants to watch me type poorly. So I'm going to create two variables that represent sort of float values for my temperature and humidity. I'll make that just a little bit larger so you can see it. I will call the DHT get Fahrenheit and get humidity values and then print those out. So we have a serial print LNF is a formatted print line. So that gives you the ability to basically pass in a format string and then the value that we want to be print. In this case, we're saying just print out a float and then we're delaying by 10 seconds. Now, if you are the kind of person that likes to look under the covers of things and see the complexity that APIs are hiding from you, you can actually right-click on this get temperature. It's another beautiful thing about VS Code. You can hover over this and see a bit more info about the actual comments for the function itself or what it does. You can also right-click and either peek the definition or go to the definition, which will open up that source file. And you'll see actually what's happening here in get temp Fahrenheit. I'm reading the temperature and I'm calling a convert C to F function to actually get I'm getting the Celsius value, converting it to Fahrenheit. But to see read temperature, I can actually go to the definition for that as well. I don't know why that would take that long. You can actually see everything that's going on here, and read temperature is basically just calling some other internal functions, getting something out of a register on the device itself, and then just returning that value. This may not seem too terribly complex, but if you scroll down a little bit more and see what's actually going on in a read, there is a lot of just sort of checking values, setting pins, reading from pins. So this is a lot of complexity that's being wrapped up in one nice little piece for us that we don't have to mess with ourselves. It's just as simple as saying, hey, give me the Fahrenheit temperature. That's all I'm here for. That's all I want. Just give me that. That's nice. So print that out to the terminal, and we are good to go. And so now what I want to do is flash this. So from the command palette, I'll open up the command palette again, and I will say, I will type in flash to flash by application local. So that is actually going to automatically put my device into DFU mode, or hopefully it will. Yes, it did. So remember what I showed earlier in the console, that's that hold down the mode button and reset. When you flash locally, if you have your device connected via serial, so again, this is important. If you're flashing locally here, you do want to be connected physically to a serial port on your machine. It'll look for your device, put it in DFU mode, and then it's going to create a binary to put on the device. And this will take just a few moments. So happy to answer any questions as we're waiting for this to flash. All right. I am back online. That's good news. And now what I can do is I can open up a serial terminal from inside Visual Studio Code. So if I go to Particle again, and search for serial monitor. This will ask me, so I automatically want to reconnect. I'll say yes. And then you'll notice it opens a new terminal window, and it's actually running a Particle CLI command. So you can run this in the CLI as well. It's Particle serial monitor and -- follow. What -- follow does is it will keep the connection open and wait for the device to restart. So as I'm flashing, my device is going offline, coming back on. This keeps that connection going. So as soon as it can reconnect, it tries to reconnect. In my case, I have a couple of devices connected, but I know that it is my Argon. So I'm going to choose Argon. My serial monitor window will open. And what I should start seeing here in a few seconds is, yeah, temperature and humidity values here. So I am at 75.2 degrees here in my office. It's not bad. I probably don't need this hoodie on. I just haven't bothered to take it off yet. 75 is not too bad. And humidity of about 50%. So it is a relatively nice day here in Austin, Texas. So sun's out. Yeah, so pretty nice day here. So thumbs up on that. Actually, no, not a thumbs up. Either give me a thumbs up, or if you wish, if you're following along, tell me what the temperature and humidity is where you are before we continue. And I'll give you all a few seconds to do that. And if you need me to slow down for just a few while you're getting caught up, please let me know. No, Wesley, you're in Austin as well. That's awesome. Very cool. I am up north. I'm up north of you. I'm up in Round Rock, which I suppose some Austinites would say means I can't say that I live in Austin, but you know, it's convenient. Tim, 77, humidity 52. If I remember correctly, Tim, you were in Florida, correct? Did you say that last week? My mind failing me? 77, 52. We're in about the same spot today. Sarasota. Hey, my memory's not failing me. Power may have failed me on Wednesday, but my memory did not. So that's great. Jim in RTP in North Carolina, in that research triangle, 75. Low humidity. All right, Wade, so cool. Not cool, but let's see if I can get that fixed. So please update the include path. Oh, Wesley, you got the same thing? All right, so a few things that might be happening there. One, I would make sure that you have the name exactly like this. I mean, you can do it either using the greater than, less than, or quotes. But make sure it is actually spelled precisely like this and capped in the right places. You want this to be the exact name of the header file. And the other thing is make sure that you actually have this lib directory and this in your local lib directory. It could be that it can't find it because the installation failed. So take a look at that. And let me know if that helps, or if y'all are still getting the same thing before we move on. Oh, Wesley, you don't have the lib directory? Okay. If you don't have the lib directory, the installation may have, yeah. So what likely may have happened, and I will say this to you all, we are overhauling the library's like installation experience. You're on Windows 10. I don't think that would. That shouldn't matter. We're overhauling the library installation experience. You may have gotten a failure and it just didn't show up or what have you. But go back into the command palette and go into install library again and make certain that you're typing in the right library name. If it was misspelled, or if you kind of forgot something, dropped a letter off at the end, you may see an error message, but it may disappear quickly. It shouldn't, but it'll try to install it, and you may see something like this: failed to install library. The The other thing that I'll say is make sure that you are logged in. So if you run particle who am I, make sure that returns a notification with to say that you're logged in. Because I do believe not every command requires you to be logged in. But I do believe to install libraries, you have to be logged in. Tim, you got that as well? Okay, so Tim said he got that the other day. You reinstalled the library again and got a message saying that something needed to be cleaned? Yeah, that's actually a good point. I'll share this now as sort of like a pro tip. If you ever get weird errors from the local compiler, or if you're switching device OS versions, or if you're switching between apps, like let's say I was working on this app this morning and I'm working on a totally different app this afternoon, a couple of handy commands that you'll want to know are the particle clean commands. So you can actually do particle clean application in device OS. That will actually basically just sort of clean up any intermediate files or linker files or binaries that may be just hanging around. Sometimes those accidentally get included by the build tool chain. And so when in doubt, clean, start over. You know, just like in life, when in doubt, clean up, start over. So Wesley, Wade, you guys, have y'all made any progress? Are we getting closer? Any of that helping? Okay, Claudia, you got it after the second time? Okay, we're getting closer. Library install failed, doing a clean, okay. No problem. Wade, the library's installed, but it still has the error. Really? Users is a directory. So let's take each of these in turn. Wade still has the error. Wade, can you make sure that you're actually logged in? Run that particle who am I command. Because we should have been able to install it. And can you also make sure that your include path is exactly what you're seeing here? I'm going to copy that into the console as well, but make sure that's your include path. And then for Wesley, yeah, you said Windows 10. Cleaning application. Wesley, can you try running the clean application and device OS? And then even if that fails, let's try installing the library a third time. And if you get the error, open up the log and show me what you see there. So if you do an install library and you try to install the wrong thing, yeah, I don't out. It should work just fine on Windows 10, but I'm just wondering where that clean issue might be there. All right, so Wesley, try to do the install again. And if you get the fail, click on the view log and show me what you get here. Copy that in. I am surprised y'all are getting this. This is I don't frequently see this as a spot where we gotta. Oh, Wesley, you're okay? Okay. Yeah, okay. All right. Sorry about that, Wesley. If you want to join back on later, or if you pick this up later, hit me up at brandon@particle.io. I am more than happy to work through this. Fix it in post. There you go. I am more than happy, Wesley, to work through you on this. Just hit me up, work with you on this. Hit me up at brandon@particle.io, and I can help you get to the root of the issue. And Claudia, yeah, absolutely, definitely a project where you have admin privileges. So it sounds like we're back on the right track for the most part. Cool. So the next step, what I'm actually going to do here, because we're writing out to the serial terminal. That's all nice and cute, but that's not anything really particle specific. What I want to do is actually expose these values as particle variables, so that I can read them from somewhere else, like from the console. So in order to do that, what I'm going to do is I'm actually going to create a few new variables. I'm going to take my float variables that were before in the loop, and I'm going to put them here as I'm going to add a few here that are globals. Tim, that's a useful thing too. If you have had the particle CLI installed in the past, you may need to update the CLI in order to make sure that it is in a newer kind of version. So I'm going to copy a couple of lines here that are in the source about creating float versions of my temp and humidity, and then we're going to create some double versions as well. That's just to do some implicit casts, so that those can be transferred into the particle console, which we'll see in just a bit. And then what I'm going to do is actually add my variables. And I'm going to add these here at the end of my setup function. And as we do that here, I'll show you a little bit, another nice little feature in Particle Workbench in Visual Studio Code. And that is some snippets that we have that are installed as a part of the process. So if I click, or if I type particle variable, or PV, and then wait for a moment, I'll actually see that there's a couple of snippets, user snippets, that we provide here for you. And that will sort of expand that into particle variable, and then allow you to choose a name. And that name in this case, I'm going to set as temp. And then we're going to pass in the temp DPL. Particle variables don't allow floats to be passed in, so we're going to need to implicitly cast these as doubles. I'll do another particle variable. And this one will be called humidity. And humidity double. And so now that I have those two, I can take these floats off of my loop because I have those defined elsewhere. I'm going to add a few more lines that all these are going to do is basically just do that implicit cast from floats into doubles here. And then those are the values that get saved as particle variables on the console side. So Wade, can you confirm you do have the lib directory? Okay, logged in. Let me go back. So you confirm you have the lib directory. You're logged in. It's an odd one. And you have the exact same include here. Are you doing a local compile or a cloud compile? That would be another question. Okay. So now that I have this in here, I am going to open the command palette again and flash my application. It's going to put my device back in DFU mode, and I'm going to go over to the particle console to actually see what is going on here. I mentioned this earlier. If you go to console.particle.io, this is sort of the view that you will see. This is all of your connected devices or even undisconnected devices. Any device that's online, it shows a little breathing cyan blue ball here for your different devices. You can page through those devices. You can view SIM cards, events, integrations, all of this stuff here on the left-hand side. I encourage you to explore a bit on your own. I mentioned products earlier. This is a place where you create those, but you can also click on individual devices and actually see the ID for your device, the version of device OS, serial number, name, last time that it came online. And as your devices are streaming events, you'll actually see these events pop up here through the event list. So you can see the last time your device was reset. You can see diagnostics for the device, all that kind of stuff as well. And then you can also, on the lower right-hand side, see your functions and variables. So this is sort of once you create a variable for your device, you can refresh that and see, hey, look, okay, so I have my temperature and humidity values here. I can click get on those, and that will reach in through the device cloud safely on the device and see, okay, look, here's a 75.2 degrees. And again, now all of a sudden 18% humidity. So that's an interesting one. So a little bit of variation on my module right there. But I can see those values as they're coming in from the console. So that's how simple it is. Really, all I had to do in my firmware in order to make this work was to declare that a few pieces of state in my device are particle variables. And that was simple. That was all I needed to do in order to work with and pull those in from the console. I can also pull these values in from web and mobile apps using our SDKs, put those on dashboards, which we'll get to see in the next section in just a little bit. So I am going to move on to particle functions, but wait, if you're still having issues, definitely keep me posted there. Not that I think that this would, you might want to restart VS Code, maybe reload the project. I don't know. It's hard to know with seeing the code specifically. Yeah, so let's move on, and we're actually going to talk through particle functions, and we're going to use the chainable LED. So this next device is going to be plugged in pretty similarly. Wade, thank you. I'm glad you did. Okay, that actually reminds me of something. On occasion, Visual Studio Code will claim that it can't resolve an include when it actually can. And this is because of the C++ extension that our extension is built on top of. So when in doubt, even if you see that red squiggly, try to compile, try to flash. If a compile and flash works, you can ignore the red squiggly, and eventually it will just go away. But yeah, that definitely, that one definitely. So I'm glad you brought that up, Wade. That was ultimately the fix. If you see the red squiggly, don't worry about it. Compile and flash, you should be fine, as you were in this case. So cool, I'm glad. So for the next piece, you're going to take your chainable LED, and this is going to plug in a similar fashion. But you want to make sure there's actually 2 ports on the bottom of this one. So you want to make sure, come on, focus. You want to make sure to plug it in on the side that says in. So where you see the in, that's actually where it's going to go in. The reason why is because these devices can actually be, as it sounds, a chainable LED. These can actually be chained together in several different devices. So I can actually take a single LED and add a second one or a third one or a fourth one and use them kind of like a strip of addressable LEDs. This is similar to the way that NeoPixels work. Have you ever worked with those before? So I'm going to plug that in on that side, on the side that says in. And then the other side, I will plug in where it says on the left-hand side, A4. So when I plug my chainable LED in, it'll turn on right away, in kind of like a white color. But the LED is not configured. It's just turning on because that pin is already writing a raw voltage. And so that's just sort of a artifact of the way that the device is set up. And wait, oh, no worries. That is not, no need to apologize for that. That's actually not uncommon. And I'm glad that you brought that up because it allowed me to address that as sort of a weird a weird thing to watch out for from time to time. So once we've got that plugged into A4, there's another library. So I'm confident this will go more smoothly for us this time. We're going to install another library, and this one is called the Grove Chainable LED. So you'll type install library Grove Chainable LED. And then once that installs, you'll notice that will also show up in our lib directory. Yep, I got it installed. So the two are there now side by side. I will include, as I did before, the Chainable LED. And again, if you see red squiggly, don't worry about it. And then initialize the Grove Chainable LED class. Now, in this case, what I'm doing is I'm saying that this is connected to the A4 and A5 pins. You'll notice when you look at your devices, when you look at the shield, that every single digital or analog pin actually is connected to 2 pins, as well as ground and power. And so in this case, this is actually using both of these pins, the A4 and the A5. And you're also specifying the number of LEDs. So if I had 6 of these here, I would want to specify 6 and say, like, I want to be able to address all of these individually. And I'll just call this LEDs. And then inside of my setup, right after I start my temperature and humidity sensor, I will call LEDs init. So I will initialize all my LEDs, in this case, just 1. And then I'm going to set the color to basically just turn it off. And set color HSB, there's actually 2 different functions you can call here. So if I go and actually see there's the red squiggly, so you can see. I'm going to ignore it. You don't have to worry about it either. If you go into source and look at the Chainable LED header file and scroll down, there's actually 2 public functions. You can set the RGB color, or you can set the hue, saturation, and brightness. You're welcome to experiment with either. I'm just going to set the hue, saturation, and brightness. And the first parameter that I pass in is the 0-based index of the LED that I'm addressing. So if I had 2, it's 0 or 1, 3, etc. I only have 1, so it's just 0 that I pass in. So the next thing is I want to actually enable my function. I want to be able to actually make this Chainable LED turn off, or turn on, excuse me. So I'm going to, outside of my setup function, create a new function called int toggle LED. Anytime that you create a particle function in your firmware, it needs to have a very specific signature. It needs to return an integer, basically a success or failure integer. And then it takes a single string that represents the arguments that you want to pass in. Now, you'll see this in a little bit, but anytime you call a function, we not only provide you the ability to call functions in firmware, but actually to pass in arguments. So I could actually pass in a comma delimited list of the H, S, and B values. And I would leave it to you, sort of an exercise for you to try that out yourself and sort of see what that process looks like. So I can actually pass in multiple arguments and just decide how I want to delimit those, or I can pass in a single argument. In this case, we're not going to use those, but you do actually have to have that set. Set somewhere. Now inside of my function, I'm going to set my color to, this is basically, it'll be just like a red, a saturation and brightness that's equivalent to red. I'm going to keep this on for about a second. So I'll delay before I turn it back off. And then I will turn a 1 to specify that I succeeded. So I will save that. And then now what I'm going to do is actually call my particle function. So same as I do in setup, right underneath my variables, I can set a particle function. I'll call it toggle LED and tell it to call the toggle LED function. So I'm deferring that execution, basically passing a reference to my toggle LED function, and then I'm off. I have that function ready to go. So I can open the command palette again. I'm going to call flash application. That will again put my device in DFU mode. And as my device comes back online, see if I can get that. Let me get the camera a little bit closer. Apologize for the, that's a little bit clearer. Even closer. As my device comes back online, you will notice that the LED will turn off. So I will know that my firmware has been applied successfully and that things are ready to go. So it looks like it's still building behind the scenes. You can always see the status of how things are going here on the lower sort of status window of Visual Studio Code. So that happened pretty fast. And Brian is letting me know, as soon as I'm done with this little piece, we're actually going to take a break and switch over. We'll take about a 10-minute break or so and switch over to the next room. And I'll do that before we actually finish this particular part of the lab. So that happened. I flashed successfully. You'll notice now my channel LED light is off. So, and now I can actually see, okay, my device came back online. I can refresh the function area C and see that I have a toggle LED function here. And notice that I can pass it an argument. I don't need to pass in that argument. I will, let me reduce my screen size here so you can see the LED as it turns on. So I'll go down to my function here and I will click call. That will turn on red for 1 second and then turn back off. And notice that I get my return code here in the console. Call it again. And voila, there you go. You're off to the races. What's cool about particle variables and functions, I'll share this with you as well, is that you can also call these from the Particle mobile app. So if I go back to my Particle mobile app and go into the device, I can see functions and variables actually listed here as in top tabs. So as soon as I go to the variables tab, it will try to retrieve those. And if I call functions, I can click on the function and do the exact same thing that I can do inside of the Particle console. So that's actually pretty cool. So I'm gonna go back over to our device here. And this time you're gonna grab the light sensor. And that would be helpful if I shared my screen. There we are. All right. Grab the light sensor, which looks like this. This is basically a photodiode that functions as like a variable resistor based on how much light it is detecting. So if I could get it to actually, there you go. So same as before, you're going to plug this into one side. And then the other side, let's see if I can remember. Make sure I did it wrong. The other side will get plugged into the A0 pin. This is an analog sensor. So you'll find A0 on the top right-hand side. Plug that in. And now you have your third and final device plugged into the shield and moving on. Video is back with no sound. Can y'all not hear me? Can y'all? No, I'm getting an okay on the sound here on this side. Can anybody else give me a thumbs up if you can hear me? Suppose give me a thumbs. You can hear me, Brian? Okay. All right. I want to keep on going. Hopefully, Jim, if you need to drop and come back, Jim, that may do it. Not sure. All right, so now once we're plugged in, we can use the sensor. So we'll go back to our firmware. And this is just a analog sensor. So I actually don't need to use a library for it. So we're free from having to install another library. I will in my setup, however, want to configure this pin. So inside of my setup, I'm going to call pin mode A0 and specify this as an input. So unlike the D7 LED from the last lab, this is a device that we are reading from, not writing to. So we're going to set it as an input. And then we're also going to add a global variable to hold the current light level that we're reading. So I'm back up at the top here underneath my temp and humidity doubles. I'm going to create another double called current light level. And now inside of my loop function, I am going to read from that analog value. So we will add a couple of lines here. And what I'm going to do is basically just do an analog read of A0. So I mentioned earlier with digital pins, when you're working with digital pins, you're dealing with ons or offs, zeros and ones. So if you're reading from a digital pin, you either get a 0 or a 1. If you're writing to it, you're either writing a low or a high, a 0 or a 1. Analog pins have a broader range, and the range, if you worked with an Arduino 6-7 years ago, an old 18 mega Arduino with an 8-bit processor, you would get values between 0 and 255 from an analog pin. That represents sort of the range of voltage between 0 and 255 that pin is currently set at. With newer microcontrollers that have higher processors, that range is larger. So because particle devices are 32-bit processors, your value is between 0 and 4095. So when you call this analog read, you're going to get a double, an integer value that represents 0 to 4095. For a light level, that's not terribly useful. So what I'm going to do is actually map that value. I'm going to call the map function to basically take my 0 to 495 and map that to an equivalent between 0 and 100%. So I'm basically asking for what's the value between 0 and 100% that you're actually reading here based on this raw value. So that effectively gives us a percentage of the light that the device is actually reading. And so now once I have that current light level, I can add an if statement. And in my if statement, what I'm going to do is just check if my current light level is over a threshold, I will publish an event to the particle console. And you'll notice here, the particle publish API is just particle.publish. You pass in a string that represents the name of the event, and then you pass in the actual payload. You don't have to pass in a payload here, but this is the place where you'll see in a little bit is where we're going to pass more data in for connecting into Azure IoT Central. And then the final parameter that you want to pass in is either public or private. We recommend private. Ultimately, what private means is only you with your token or your devices can subscribe to events published from your devices. There are reasons sometimes you may want to publish events publicly. If you have two devices that are owned by different people speaking across, talking across the space, you can publish public events between them. But public events can be subscribed to by anybody, whereas private events are your devices or your secrets, where you have your secret key only. So we'll publish, and then we're off to the races. So I'm going to flash again. So open up the console, and we'll do flash application. And as that is doing its thing, I'm actually going to wait for my device to come back online. So putting my device in DFU mode, build some firmware, and then update it. And you'll see that I'll get events streaming across here as I go through. Yeah, so Tim, does private only apply to publish? Yes, it's only applying to publish. When you subscribe on the other end, you'll want to specify whether or not you're subscribing to public events or to my devices, and that's detailed in the particle docs in terms of what that looks like. So for instance, if I were to do a particle subscribe somewhere here, like in my setup, I'll show you. So if I did a particle subscribe, come on. If I did particle subscribe, the variables that I want to pass are the name, right, foo, the event handler, and then I think in the case of this, the third is the scope. And the scope can be something like, let's see. So if I wanted to pass in a scope, let's do scope. I would say my devices, right? I can only, this is the subscription way of basically saying I only want to subscribe to events for my devices versus all devices, right? So that's what you would do on the subscribe side. All right. So I have my device coming back online, and look, I'm actually getting values now. I'm seeing 64. This is getting logged here, and then the payload is showing up right here. So if I were to take my phone and actually turn on, I should be able to affect this, depending on where you are, I should be able to affect this by turning on the flashlight on my phone and shining it right at that chainable, or right at that resistor, the light meter, and getting a different value as it comes through. So let me get it right on top there. So maybe slightly more, seeing slightly more a little bit there. So you can see that value actually change. So that is your very quick particle publish. Now, if you are using the particle CLI, another thing that you can do inside of the CLI is actually subscribe to events inside CLI as well. So you can run a command like particle subscribe and then the name of the event. In this case, I'm actually going to use a prefix filter. So one of the features that we provide is if you actually use forward slashes, you can add levels, basically subscription filters to your devices. So I can do light meter / off on, light meter / level, and I can subscribe to all of those just by using everything before the slash. So I can say particle subscribe light meter mine. I'll see a notice that I've subscribed to my own subscriptions, and then I'll see those start to stream across along with the actual values as well. And here I can see the full payload as it comes in, which is cool. So cancel out of that. All right. So before we move on to the integration, so we've done now that we've explored the particle subscribe piece, we're going to move on to the Azure IoT piece and sort of make that connection between particle and Azure IoT Central. Give me a thumbs up if you're still with me here. If you have any questions, concerns, anything like that before we move on. All right. So I'm going to open up Keynote here and move on to the last little set of slides. Wade, web console isn't receiving events. Try refreshing the screen. Sometimes, Wade, if you get, if we close the socket connection on our end, it may look like nothing's happening, but try refreshing the screen and you should see that. Start to see things come through. All right, I'll open up the last set of slides here. In addition, let me do this piece as well. Claudia, good question. Yeah, I will. I will provide the slides to Brian, and he can send the slides out to everybody as a follow up after the event. Definitely. Thanks for asking. And maybe it's just my computer is just being slow today. So I don't know why this is taking forever to open. But if in the meantime, you want to head over to the chapter 3 in the workshop content, in the workshop lab, we will talk a bit about integrations. Oh boy, that is slow. All right, let me try. It's not the end of the world if Keynote decides not to cooperate, but it would be nice if it actually open. So quit. It's very strange. Keynote has decided not to cooperate. So we will just move on, actually, not strictly necessary. When I talked through the particle integrations piece previously, one of the things that I mentioned is that, we recognize that an IoT application consists of a lot more than just the actual hardware piece itself. There's a whole lot of other moving pieces and aspects to that story that you're really trying to run down. You're creating a hardware solution, but ultimately the reason why you're using connectivity is because you want to build a web app or a mobile app that can control or read from those devices, or you want to build dashboards. And in many cases, what you're wanting to do is actually to backhaul your data to your own cloud providers to do something interesting with it, whether it's time series data, or you're working with Influx, or whether it's something like you want to work with streaming analytics in Azure, you're working with AWS IoT. And we recognize that all of those are systems that you want to work with to actually do something else with the data that's a part of your IoT solution. And so the command center for actually creating integrations is in this little hub and spoke diagram in the particle console. That was insane. I don't think I've ever had to wait that long for a keynote presentation open. It's not even that big a one. That hub and spoke model is something that you want to be able to create. And the way that process works, I'll go ahead and go on to the slides now, is you create integrations by creating webhooks. And webhooks are your way of basically saying, I want to create a connection between two systems. The system can catch a webhook. So anytime you see this event on my end, so basically what you're saying is, anytime I want to do a subscription here inside of my webhook, and anytime you see an event with this name, call this URL and send this information to it. That's sort of the secret sauce of creating that sort of an integration. And the same thing works with Azure IoT, with Google Cloud. You're basically creating a connection between those two systems. And that is something that we're going to explore here in this next hands-on lab section. So we're going to get right to it. And I'm going to jump down to the section. I would encourage you to go back later and you can spend some time. We already went through the CLI just a little bit, but there's some extra steps here in the hands-on lab where you can mess with that. You can also explore the device collect API, just firing curl commands to see what your devices are actually doing, which is kind of fun. But we're actually going to go straight into integrating with Azure IoT Central. And so I would encourage you to click on in the docs in section 3, excuse me, in the hands-on lab section, go to set up Azure IoT Central. And if you don't already have an Azure account, click the link there to create a new account. I already do have an account. And so what I'm going to do next is actually go into the build your IoT application link. So that's the second link that our good friend Paul DiCarlo has added there. So definitely click on that link as well. And this is sort of your IoT Central dashboard. So it actually gives you a couple of different preview apps that you can look at for things like logistics and inventory management. You can look at samples for governmental applications, healthcare, some interesting stuff there, and you can learn more about these templates. But what we want to do is actually click the custom app here. And if you're concerned at all about pricing for IoT Central, all of this you can test drive with a 7-day trial. So anything you create today, you have 7 days to fiddle with before you have to pay for it. Definitely remember to turn it off, shut it down. But for now, you're not going to be charged anything for going through this lab. So once you click on this, you're going to give your IoT Central application a name and a URL. They both have to be globally unique. So I'm going to call this my particle Monday sensor. So particle Monday sensor. So you'll see this URL will be your top level URL that you'll be able to access this particle Monday sensor.azure-iotcentral.com. Let me make my screen a little bit bigger. And I'm trying to think, do I need, in the application template, I will pick custom application, right? And from there, you want to make sure that your billing info here is correct in terms of your subscription. It'll likely look different for you. And then choose a location that is close to where you are. So I'm in the United States. I'm going to pick United States, and then I'm going to click Create. Now your application is going to be provisioned, and this will take a few moments. And then what will happen as soon as that's done is you'll be taken to your, excuse me, IoT Central dashboard. Now, there's a lot of stuff in here. You may see a few things. There's a quick start demo, some docs, tutorials, things like that. Where we're actually going to go to is, we're not going to do anything else in here yet. Well, actually, yeah, we are. If you ever need to know where you are, right, your URL. So I did Particle Monday censor.azure.iotcentral.com. You can always figure out, if you forget that URL, you don't have to go back into Azure proper. You can actually go to apps.azure.iotcentral.com and then My Apps. And if you go to that URL, that'll actually show you all of your own Azure IoT Central applications. So you can always get right back to those if you lose reference to which one that you're in. So the way that IoT Central works is you define the things that you want to track, or the devices that you want to manage, by creating templates. And a device template represents a kind of device that you want to apply certain things to. And so I will go into the device, click on the device templates app settings here on the left-hand side, and then I'll click new. And for your template, you have a couple of canned ones here for Windows IoT Core, Raspberry Pi, for the MX chip, sensor tile. We're working with a particle device, so I'm going to click custom, and I'm going to enter the name for my device template, and I'm going to call it, you can call it whatever you want. I'm going to call it particle argon. This is going to be my template for all of my argon devices in this application. And once that template's created, you'll see that you have a couple of interesting things here. Measurements. So any device template is where you basically specify things like settings and properties on your devices, commands for being able to call things back on your devices, rules that you want to respond to create dashboards, and measurements, the things that we'll look at today. With measurements, you can actually track a number of different things. If you have a GPS module, you can track the location of a device. You can track events that come in, state of certain variables, or you can just capture raw telemetry. And telemetry represents sensor data that we're going to capture on the other side. And so we're actually going to fill in we're going to create telemetry options, telemetry to represent the temperature, the humidity, and then the light level that we're ultimately going to be sending in from our firmware here in a little bit. So I'm going to click on the new option, or the new menu, and click telemetry. And we're going to give this a name of temperature. And that's the friendly display name. And then the field name is going to be what we're going to be sending in on our payload. So we'll write this on the firmware side in a little bit, but you want to choose a name here that will represent what you're sending along through the Particle Device Cloud into Azure IoT Central. For units, we'll pass in DEGF, since we're sending in Fahrenheit. Minimum value of 0, 100 value of 110, because it gets hot here in Texas, and 0 decimal places. And we'll click save. And you'll see as I was creating that I was actually getting some info here. This is just sample data. This is obviously not real data because we haven't made the connection yet, but this shows you kind of what you can expect that data to look like as you create it. So we're going to go in and create 2 more. We're going to create telemetry now for humidity. And we're going to call it humidity. Lowercase h for the field name. Units are percentage, minimum value 0, maximum 0 is 100, 100. And no decimal places on that one. Click save. And you'll notice too, you can actually, I forgot to mention this, but you can actually change the colors on these too, if you prefer. So I'm going to change my humidity more to like a yellow, or the green. I'm going to change my temperature to more like a green color. And then, no, that's not too close in green. So let me do a different green for this. So do look more like a blue there. Again, not happy. Orange. There we go. And then now one more for my light level. We'll call this light level. And light. Also a percentage, 0 to 100. And decimal places of 2. And I'll take the default purple color here. I like that. So now that I have all 3 of these values, I'll start to see some things sort of pop in. Again, this is just sample data, but I can change the way that I want these to look, create stacked, shared shared charts if I want these to all show up sort of in the same range together. But that's my telemetry. Those are the sort of 3 starting pieces. And once I've done that, I've created a template that I can now connect to my Particle device. But in order to go to the next step, I actually need to make a connection between Particle and between IoT Central. And the way that that works is by using something called the Azure IoT Central device bridge. And this is actually linked in from your from the docs, from the hands-on lab instructions. And the IoT Central device bridge is basically a piece of middleware that will be listening for webhooks from the Particle device cloud, and will then take those inbound webhooks and turn around and forward them into Azure IoT Central. Now, you don't have to use this solution. This is basically just a Node.js application that serves as the middleware piece that sits between the two. You don't have to deploy this to Azure. You can run this on your own servers. You can run it locally for the purposes of testing. One of the nice things about this project is that there is a simple an Azure template basically that gives you the ability to create all of the needed pieces for this. And so it creates all the resources that you need for a Azure function, a key vault, etc. So once you have this open, you want to click on this deploy to Azure button. And what this will do is it's actually going to provision a, I can't remember what the name that Microsoft has for this, but this is basically a template that will provision a couple of services for you. You're going to either select or choose a resource group for this. So let me call my group, I'm going on this Monday theme. I'm gonna call this Monday group. Thank you, Brian. ARM templates, Azure resource, ARM templates. Which as a firmware and hardware person makes me think of a different kind of ARM, but yes, that's correct. And then choose a location. And now I need a scope ID and an SAS central key from my, make sure this is on, from my IoT Central application. And so I'm going to need to go back over to IoT Central in order to get this. And those are, you can actually get those in from, let me go to the right place here. If you go into administration and access tokens, no, device connection, yeah. You can grab the scope here. I'll take that scope and I will copy that in here. And then you want to get your SAS token. So you'll see a couple of tokens here. Copy the primary key, close that, go back over, paste that key in here. Don't worry, I'll shut all this down after this workshop. And then click agree and purchase. Like I mentioned, you are creating new instances in Azure, so you want to check pricing. Definitely after the workshop today, don't leave these things just sort of hanging around and accruing. They're not going to cost you much. I think it's just thousands, tens of thousands of messages in your middleware for a few pennies. So it's not going to cost you much, but you know, with anything with Azure, any other cloud provider, you always want to pay attention when you're creating resources to go back and clean them up if you're just playing around and configuring things. So this deployment is going to take a couple of minutes. I'm happy to answer any questions while this is going on. And definitely give me a thumbs up if you're still with me, still trucking, having any concerns, problems, let me know. While we're waiting for things to happen in the cloud. No problem, Jim. This is obviously this is the part where it can be easier to fall behind a little bit because we're creating things and moving in a bunch of different places. As I mentioned a few times already, the resources, the docs, the content for the lab will stay live and available. These videos will be published and available for you as well. So you'll always be able to go back if you get behind or anything like that. And of course, if you have any questions for me after this, you can email me. Email me at brandon@particle.io. I'm happy to answer any questions or concerns, etc. It's still deploying. Tim, following along, I'm going to have to go and play back and go through slowly. I put 100%. Oh, good on the particle and just on the other side. So Sergis, that's a great question. Is it possible to send data directly to Azure instead of sending it to the Particle device cloud first? Yes, yes, it is. There is a firmware library called the Azure IoT Central Bridge that you're welcome to search for and you can look up. That actually does go directly into Azure IoT Central. So if that's your preference, you are welcome to do that. I recommend using the Particle Device Cloud because we provide all the security and management of your device. You're basically going completely around the Particle Device Cloud at that point, which has a couple of drawbacks. One is you're not getting the advantage of using the Particle Device Cloud for pub sub, functions, variables, those kinds of things. The other drawback is that your firmware binary will be way, way larger because you're having to manually configure some TLS connections and whatnot on the Azure side, on the IoT Central side, in order to make that handshake between the two. Wade, not an Azure question, but my Argon will blink cyan rapidly every few minutes for like 10 seconds. Do you know what message it's trying to send to me? I don't know. That's interesting. I don't think it's trying, as far as I'm aware, I don't think it's trying to send you any kind of a message. That's kind of funny. And this is happening pretty regularly. Maybe I just haven't observed this. If a cyan blinking could just be that your Wi-Fi is reestablishing a Wi-Fi connection. So it tends to happen when a device comes online. It starts white before the radio is on, for Wi-Fi at least. It goes to blinking green when it's looking for the Wi-Fi. And it goes to blinking cyan when it is connected to Wi-Fi, but it's connecting to the device cloud. And it goes to breathing cyan when it's connected to the Particle device cloud. So when you're seeing that blinking, Wade, it could be a very brief disconnection from the Particle device cloud, but that shouldn't be happening very often. You may just want to reset the device and see what's going on. And then Tim, I know what you meant, that you're fine on the Particle end. Go back through and take your time. Yeah, for sure. This definitely takes a little while. And that's good. I'm glad you had questions because I was able to get this done. So I've got my resource group. So now I can go into my resource group now that the deployment is done. And I'm going to go into my app service, the little lightning bolt here. And because this is a Node.js application, I actually need to do some configuration on this end in order for it to actually start receiving webhooks from my side. So I actually need to do an npm install. So I want to click on the IoTC integration function. That will actually open up the actual code itself. And I will open up the console. And inside the console here, my cloud console, I'll type npm install and click enter. This is going to take a few minutes. What's happening on this side is that it's actually going through, and as you would when you run npm install on a local machine or when you're deploying to a Heroku or another instance, it's going through and doing all that for you. You can actually see what's happening here on the app side. This is basically just a simple app with a single endpoint that's just listening for an instance, listening for a message, getting your secret out of your key vault, and then forwarding those messages into IoT Central. So we're going to leave that npm install to run for a little while, and we're going to go back over to the Particle console side, and we're going to create a new integration. Now, in this case, I'm going to go down to the webhook integration directly. There is an IoT Hub integration, but that does not yet allow you to go directly into IoT Central, which is something that hopefully we can resolve in the near term. But for now, webhook is what you're going to create. And you're going to give it a name of env vals, env-vals. You want the request type to be post. The request form will be JSON. And then you're going to choose the device. In my case, just Happy Monday is the name of the device that I want. So I'm going to choose Happy Monday. And now the URL is the Hey folks, sorry about that. Can y'all hear me now? Hopefully. Hello, hello. Yep, okay. I think my mic seems to be okay, so hopefully back. Apologies. Power did not go out this time. No idea what happened. I just sort of lost connection on everything there for a few minutes. So let me back up and reshare my screen and show, because I think it may have gone out for just a few minutes. What I needed to do on the integration side was to get that firmware, to get that URL. That URL needs to go here with an event name that we'll set in firmware in a little bit here. I want to set the request format to JSON and target just this specific device. And then under advanced settings, I want to expand that and actually go from the default JSON payload into custom. And the custom payload needs to look like this. This is what the middleware piece expects to see in order to function, in order to make that connection between the two. If you get a little bad string validation error here, ignore that. It's not a bad string, it's fine. And you'll click save, and now you'll have that payload ready to go. So what we're gonna do now is actually update our firmware. And what I was saying before I realized that my audio had completely gone out was that it's actually not a great practice to use these blocking delays in your firmware. It's fine for prototyping, but what's happening during this period is you are preventing execution from actually happening on the firmware side. Makes it tougher. You're actually, it's not a horrible thing because we actually still can respond to variables and function calls in the background, but it does stop your firmware from really being able to do anything else. And so what we like to recommend instead is that you use an approach for non-blocking working with non-blocking delays. And so the way that works is at the top of my function or the top of my sketch, I am going to create a couple of variables, longs, to represent the number of milliseconds that have passed since the last time that I did a check, and then the interval, which is basically every 5 seconds, I want to check and publish values. So we can increase this to 10 if we wanted to, like we had before, 10 seconds, but 5 seconds, I'll do that check. Now what I want to do inside of my loop is, this is actually the bulk of where we're going to make those changes. I'm going to set my current millis to, basically this function here, millis, is the number of milliseconds that have passed since your device was powered back up. It rolls over, but it's always a useful indicator of how much time has elapsed in your firmware if you're waiting for an interval to check something. So once I've actually added that, I'm going to create an if statement that will sort of contain the rest of what's going on inside of my firmware. What I'm doing here is just checking how much time has passed, subtract that from the last time that I have checked. In this case, it starts as 0. And if at least 5 seconds have passed since the last time I've checked, run what's inside of this if statement again. And that is sort of the replacement for the delay there. So we're going to delete that. We're going to take all the other code that's in here, and we're going to put that inside of this if statement. So now every 5 seconds, it'll check the temp and humidity, write to the serial console, and then publish any particle variables. So that's the first little piece I wanted to do in order to get the rest of this doing the thing that it's supposed to be doing. So now once we have done that, we're ready to actually publish our data and get it into IoT Central. And the way that this is going to work is we're going to need another library in order to do this, because we're going to be working with JSON objects. And if you've ever worked with JSON payloads in C or C++ before, there's a lot of manual string replacement that has to happen. There's a great library that actually makes that entire process a whole lot easier to work with. So the name of the library is JSON Parser Generator, RK. So you'll pass that in, search for that. And once that library is installed, you can add an include statement at the top of your project. And just like it sounds, this library allows you to do two things. It allows you to parse JSON objects, which we're not going to do here today, but it also allows you to create valid JSON objects that you can send along into the Particle Device Cloud, and in our case, ultimately into Azure IoT Central. So once we've installed that library, we're going to create another function at the top of our program, and this is going to create event payload. This is going to take 3 things: the temperature, the humidity, and the light level. And what it does after that is it works with that JSON parser generator object to create what's called a static JSON writer. And this is basically just an array with 256 bytes available in it. So I can add, basically this allows me to dynamically build up a JSON object without having to do a lot of string replacement. So I'm creating my object, passing in a pointer to this JSON writer. And then anytime I insert a key value, it does the nice inserting curly braces and arrays and all that kind of stuff. And as soon as my scope ends here, right, because this is just an empty scope, it's not inside of an if statement, it's not a function. When my scope ends, it closes the JSON object valid, and now I have something that I can do with that. That's something that I'm going to do is to actually publish my particle, publish to the Particle Device Cloud this payload. This will be an actual JSON object, and the way that I convert that into a C string for publishing to the Particle Device Cloud is just to call jw.getBuffer, and that gives me that C string representation of my dynamic object here, and then I'm publishing that as a private event. So now the last piece is to actually call this new function, this create event payload function. So I'll add that here, create event payload, pass in temperature, humidity, current light level, and all 3 of those will be sent to the Particle Device Cloud. So I will open up the command palette again, flash my application, and I will go back to the Particle console for my device. Actually, excuse me, I'll go here. I'm going to stay in my integration here. I'm going to go back to the console, and as my device is coming online, I should actually start to see those payloads. Let's see, where's my Happy Monday? So I'm still flashing here in the background. But as my device comes online, I'll start to see events, and I'll see my brand new event that will then be ready to get pushed into Azure IoT Central. You may see some warnings here with libraries. Don't worry if that's just a warning, especially if it's in a library. That's not on you. So flash successfully. I'm seeing green, soon to see cyan on my Argon. Hopefully you are soon as well. I'm back on, and here we go. Here's my first, and you see I have a nice little JSON object here, prettified. There's the raw version if you want to see it, but temperature, humidity, light level, all being sent across, and those are publishing every 5 seconds or so. So the next step, now that I've got this here, I can go back into my integration and refresh the integration view and actually see what is happening on this side. Okay, so I'll see that I'm actually getting some errors here. And if I look and inspect any one of these, I'm seeing an error status of 403. And y'all remember what 403 is, right? 403 is not authorized or forbidden, right? Unable to register device. Now, this is what you want to see at this point. This is a good thing. If you go into your middleware, you may actually see this here as well. If I it looks like application was terminated. I may have to reconnect. That you will see this in the logs also for your function logs. So, okay, yep, so there you go, unable to register. So that's the message being sent back. This is good because we actually want to go into our device template, click on the template that you created. No, actually, that's not the place. You want to go into your devices list, and there's a little menu up here called unassociated devices. And if you click on that, you should actually see a device. This is your Argon. Won't be the same. This is the device ID of your Argon. So if you see this here, then you have made the connection. There's one final piece to really make the magic happen. Is you'll click here, click the checkbox next to it, and go up to the little, I guess, ID card icon here next to the trash can. And that is the associate button. You want to click that, and you choose a template, your particle Argon, click associate, and you have made the connection between your devices. If you now click on templates, I think I did. Oh, I thought I did. Maybe I didn't do it correctly. Pick it, associate, be patient. Maybe it takes a moment. Should not be in this list any longer. And it is. Why is it still in the list? Associate, pick the template, click associate. That's odd. I don't think I have seen that before. It is possible. So bear with me for just a second because I just did this workshop last week. So while y'all are catching up, it is possible that what was the URL that I said you could go to hold on a second. It's possible because this device is associated with another instance that I messed with last week that I need to go unassociated there. But I didn't see an error. So I'm going to go to my apps, and the app that I created last week was this Powers On app. So I'm going to go into devices, Particle Argon, this device, and I am going to delete this device. Jim, this is representative of my experience with Azure setups. Sometimes, yeah, I will say, like, this is probably a bit of an edge case if it was because I had the same device already provisioned somewhere else. Yes, that's probably the unexpected error. So but yeah, I mean, it can happen. Let me go in and actually try to associate this again. Click the template, associate. I didn't see a message yet. Still the simulated device. All right, I'm going to give that just a minute and sort of keep on going. The unexpected error again. Hopefully you are having more success with the association than I did just this moment. So I'm actually going to go back into the device template because we're going to do the last piece here. And we're actually going to create some dashboards that we can use to view the real data that's streaming from our device, right? Remember, we're sending this data every 5 seconds. We want to take that. And now that we have it in IoT Central, there's a lot that we can do with it. But one of the easiest things is actually to create some dashboard UI around it. So we're going to go back into the device template, click on Particle Argon, and we're going to click on this particle, this dashboard tab. And you'll notice you have a lot of different options for creating dashboards. There's things that we can do for adding images, line charts, bar charts, KPIs, all that wonderful stuff. What we're going to start with here is we're going to configure some last known values. So I'm going to create a last known value for last temp. We're going to say we want the telemetry and then pick the temperature here. So that'll be our last known value. That'll show up here on the main part of the screen. And we're going to do 2 more. A last known value for humidity, if one can spell. Boom. And a last known value for light level. I'm going to take a light level for that one. So now that we've got those 3, those will show up here like this. We can make this one a little bit larger since it's got a different, since it actually has a couple of significant digits there. And now for the last one, we're going to create a line chart. And for a line chart, we're going to give it a title of invals. Show the legend of the last axis. We're going to set the range to, let's do the past hour. You can set this accordingly, whatever you want. I'm going to choose all 3 of these measures and click Save. And now I have a nice little line chart. You notice I can make these things larger. I can drag them around. But this is the dashboard I want to see and have it connected actually to my real device. So this has all been saved. Again, I'm making a change in the template, and then I can see this show up in individual devices. So if I click on my devices, you can always view what a simulated data looks like. The simulated data looks like on a simulated device. IoT Central provides you this ability so you can just sort of kind of see what things will look like. And you'll see this little message here that is just simulated data that's coming in. But this is what my dashboard looks like. It's just kind of cool here. So I can see what's going on there. I can click on an individual. I can click on the line chart and actually go back here. And then I can see it from my real devices too. So I'm going to try to reassociate this device just one last time. And pick the template and associate it. And hopefully that will work this time. If not, I'm going to cut bait and say that it's something with trying to use the same device across different IoT Central instances. But again, like I said, hopefully you have had success with this and you can come back to the resources and the docs and work through it. I know this Azure part of things takes a little bit longer to sort of chain everything together. Still getting that unexpected error. It's funny. We should take that. I'm going to take that error code here and search for it. Why not? Anybody else seeing that? Or can give me a thumbs up if you're following along, if you're actually following along with this and trying to get a device. If you're like I said, if you're messing with it later, email me, Brandon@particle.io. Let me know how it goes. Hopefully it'll go better for you than this. You can check the video from Wednesday, which I know Brian has made available. It definitely did work on Wednesday. I don't know why it's not working this morning, but hey, demos are made to fail, especially when done live. Yeah, unable to register device. So we have things connected here on these 2 sides. It's just a matter of actually getting the association. The important part here I'll mention is that this association has to happen in order for your device to be approved. So once that association does happen and you choose a template, you will actually start to see the logs say, this is successful. We got the message through. The Particle console will start giving you 200 messages as the devices are, as your data starts to stream in. So cool. And then back in the documentation, there's a whole lot more resources that Paul has provided on working with IoT Central, app templates, architecture, adding devices, all that kind of stuff. We won't go through any of that specifically now, but I'm still getting that error. So yeah. So I will, I'm going to stop sharing at this point because we are actually done with what I had for the workshop today. And I'm happy to answer any questions in the last few moments that we have here. And we wrapped things up a little bit early, but definitely throw questions in chat right now if you've got them. I'll answer those in the next few minutes. Feel free to email me again, brandon@particle.io. I'll put my email there into chat if you ever need to ask me anything. You can also follow me on Twitter @BrandonSatrom. I'm reasonably active on Twitter, saying some things from time to time. So feel free to follow me there as well.
Thanks for watching.